Okay, let's talk about MDF, which is far and away the most common material used for trim, various kinds of molding on interior finish inside a building. MDF stands for medium density fiberboard, and the nice thing about it is that it's all industrial waste basically. It's sawdust and glue, and they press it together, and they can form various shapes. It's pre-primed. It's a very efficient use of materials. We're going to talk a little more about the kind of the pros and cons of it, but for now, think about how it's been designed as a replacement for solid wood. Okay, you can get it in all the traditional dimensions. You know, you can get it from 1 by 2 all the way up to 1 by 12, and you can get it in basically any kind of molding that used to be available in wood. Moving on, it's very cheap. I would say, depending on what you're getting, it's either side of $1 a foot. It's uniform. It's really easy to cut the stuff. You can take a router to it. As long as it's not getting wet, it's pretty dimensionally stable. It's really easy to paint. It's has some very positive attributes. The downside of it is it's pretty heavy, and it's not going to hurt anybody if you're carrying it around, but compared to wood, it's quite a bit heavier. You can't carry as much around. It doesn't have the same like stiffness as wood. If you wanted to carry a 20-foot long pine 1 by 4, you could carry it with one hand and it would stay perfectly straight. If you tried to carry around a 16-foot 1 by 4 MDF, it would want to bend and break in half. So you have to be a little more careful with it when you're moving it around. It's not very good with water contact. If you put it in bathrooms, laundry rooms, kitchens, places that could theoretically see water, especially around the bathtub, it's kind of a nightmare. It will absorb water like a sponge. It'll swell. I've seen it swell up to like twice its thickness. So if you started out with 1 by MDF, 3/4 of an inch thick, and it gets consistent water on it, it'll swell up to an inch and a half thick. Okay, so it's pretty wild what can happen with that. It's also very easily damaged, more so than wood. Outside corners get banged up pretty bad. The lawn, or not the lawnmower, the vacuum cleaner crashes into it, toys crashing into it, people kicking it. It just really gets beat up. And then the other kind of downside of it is you can tell an MDF molding over a wood molding. It doesn't take a profile as crisply as a piece of wood does. And then the biggest thing that we'll talk about in future lectures is that the binders and the glue that they use to hold this stuff together is urea formaldehyde, and so that could potentially off gas. That formaldehyde off gassing into the house can make people sick. That I would say that's kind of a severe scenario, as it can make people sick, but it does contain formaldehyde. It is recommended that you seal the ends of all of your cuts if you're putting it inside the house. All right. So this says MDF installation, but this could be whatever kind of installation you're doing. Personally, I'm using poplar or maple, like a paint grade wood, for all of my interior work at my house. And the reason is, I'll tell you briefly, MDF, if you get MDF, it's only going to be 11/16 thick, and it's going to have an eased edge. It's going to have a slight bevel on it. Most people might not be able to tell, but I've gotten to the point that I can never go back now when I'm installing casing or any kind of molding in my house. If I'm casing around a door or casing around a window, I want the side casing and the head casing to be flush. I want them to plane out perfectly. And then I've gotten accustomed to older homes having 13/16 inch thick trim. You might not think that that's that big of a deal, but I can spot 11/16 thick casing from 1 mile away over 13/16 thick. And then the other thing, like I mentioned, having the side casing and the head casing in the same plane, if you have an eased edge, you'll see a divot where those two pieces meet. And so if you have just flat, square, 13/16 thick casing, you can make those planes exactly flush, and it looks like it's just one piece that they cut a window out of. So it looks a lot nicer. Okay, but anyway, moving on. When we talk about casing, that is a piece of molding or a piece of trim that goes around doors or windows generally, and it's nailed on the face of the wall. Okay, this gets confused a lot. People want to call this the jamb, or people want to call it weird things, but this profile around the window is called casing. Okay, this is the side casing here. This is the head casing. Okay, this little piece that's kind of projecting out past between the side casing and the head casing, that's called a fillet. Okay, and I believe that you could call this a crown up here since it has a little spring angle to it. And we'll talk about these parts later on. Okay. All right. Window stops or jamb extensions, those are a piece of trim that are going to get nailed to the trimmers when we're trimming out a window. Okay, so remember our windows are sized a 1/2 inch under the rough opening in the framing. So we're going to have a gap all the way around the window that we need to conceal with some kind of piece of molding. Okay, and those are either stops, traditionally called jamb extensions. And those are going to be the thickness, they're going to be ripped from whatever, if we ran a tape measure into the face of the window and got a number to the sheetrock, the face of the sheetrock, that's what we would rip our jamb extensions to. And usually there's some kind of taper. Think about all of the tapes and stuff that we used on the outside of the window to flash around the window. That window is not sitting perfectly flat against the framing. Okay, oftentimes there's a bit of a taper that needs to be cut. There's a couple things you can do if you're using, I would say if you're using MDF or if you're using poplar, you could either try and rip a taper with your circular saw, or you could rip it so that it's just a little proud of the face of the sheetrock and then plane it down with a nice sharp block plane. Okay, that would get you a really nice look. The critical thing with these jamb extensions is that we want to have a parallel reveal. Okay, there's going to be a little bit of window frame that we can see, and we want, I don't care if this thing isn't plumb in here. Okay, as long as it operates fine, we're going to hide the fact that it might not be square or it might not be plumb with those jamb extensions. Okay, so we want to nail this jamb extension in so that when it gets nailed to the trimmer, there's an equal distance from the face of the jamb extension to the edge of that window frame. Okay, we want to see a consistent 1/2 inch or whatever the case may be. Okay, we want that to be parallel all the way around. Okay, we want to see the same reveal on both sides and the same reveal on the top. Okay, the bottom's a different story. We'll talk about that in a minute here. What you can do is, with a little bit of figuring and drawing in the opening and drawing on the window, we could pre-make these jamb extensions. Okay, we could pre-make them so that when it goes in, we have a parallel reveal here, and it's nailed together on these corners, and we just slip it into place. Maybe we put some shims in here or there to hold those parallel to the window frame and nail them in. Okay. When I'm out at the house doing this, I'll take a video of this and show everybody. Okay. All right. Baseboards, like I said, maybe you want to use poplar, maybe you want to use MDF. This is just square stock used as baseboard. We'll talk about some different applications that we can do with this, but baseboard is going to run along the bottom. It's going to cover up that joint between the floor and the wall. Okay. When we're nailing baseboard on, usually we just want to butt the inside corners. Okay, and there's a couple ways we could go with this. Outside corners, we're always going to want a miter. Okay, and the point here is we never want to see end grain exposed. Okay, so if we're just using flat rectangular stock, we can butt these inside corners. Okay, and no one's going to see any end grain. If we're doing an outside corner, we're going to want to cut a 45-degree miter or bevel, depending on how this thing's oriented. But at any rate, this is going to meet at a 45-degree angle, and that end grain is going to be captured. Okay. If we're using a one-piece baseboard that has a profile milled on it, we're going to have to cut a bevel on the inside corner also. Okay. In this case, they're using rectangular stock, and then they're building it up with base shoe, and then they're building it up on top with some base cap. And this is kind of nice because just like I talked earlier about with that base shoe, if we're hiding any imperfections, any high spots, low spots in the floor, this base shoe will follow those a lot easier than this wider stock, and it'll cover those up. Same thing with this base cap. If there's any dips in the wall, this flat, wider stock is going to want to span those, whereas this base cap, you can push it in tight and it'll be easier to caulk and conceal those spots. Okay, so let's just say you're using flat rectangular stock and base shoe and base cap. I would butt the joints for the rectangular stock, and I would either miter or cope these joints. And there's a little, they addressed it in the video, the crown molding video, about coping. I'm not going to get too deep into that right now. That's more for the finished carpentry class. Okay. We always want to nail through the baseboard or whatever molding we're installing through the sheetrock into studs. We want solid nailer behind whatever we're nailing into. We're going to use our finish gun, and what I like to do, and I'll take a video of this at the house as well, is I like to find a stud. Usually I'll go to one of the receptacles, knock on either side of the receptacle and find where the framing is, and then I'll just set my tape measure on that point and extend it out along the length of the wall, and as soon as I nail that first one in, I have my tape measure out and I can see where 16-inch increments are all along the length of that baseboard, and I can nail the baseboard into something solid. Okay. When we install baseboard in areas that are going to get carpeted, we want to leave a 1/2-inch gap between the subfloor and the baseboard. And the reason is we want to come back and tuck the carpet underneath that baseboard. Okay. In other areas, hard surface areas like laminate or tile or something like that, we're going to make a decision. Do we want to space it up, install the floor, and then come back with base shoe? Or if we're just going to use a one-piece baseboard, we'd probably want to put the floor in first and then come back with the baseboard and set that on top of the finished floor.